Welcome all my dear student of FYBSc physics class. Today we are going to start second semester, and in this second semester the first physics paper or paper physics first is nothing but heat and thermodynamics. Now in this lecture we are going to see some introductory part of this chapter. That means what is thermodynamic, what are the basic concepts of thermodynamics, then equation of states, limitation of equation of state or perfect gas equation, and etc. First of all, in the introductory part of this chapter, that is, the title of the first chapter is Fundamentals of Thermodynamics. What is meant by thermodynamics? Thermo means heat. Thermo means heat, and dynamics means transfer or motion of science. So, as thermo is the heat, thermo means heat, and dynamics means the motion of science or transfer phenomenon. Hence the name thermodynamics. Now we are going to define the term thermodynamics. Thermodynamics is the branch of science which deals with the conversion of heat energy into other form of energy. What I say? Heat energy. Thermodynamics is the branch of science which deals with the conversion of heat energy into other forms of energy. Other form of energy means what? There may be mechanical energy, electrical energy, and chemical energy, etc. And vice versa. What I say? Thermodynamics is the branch of science which deals with the conversion of heat energy into other forms of energy. In other forms of energy, we can say that mechanical energy, electrical energy, chemical energy, etc. Or other form of energy can be transferred or can be converted into heat energy. Okay. I am again going to repeat the definition of thermodynamics. Thermodynamics is the branch of science which deals with the conversion of heat energy into other form of energy and vice versa. Okay. So, in order to understand the thermodynamics, we should know some basic concepts regarding thermodynamics. The first concept, basic concept, is system. What is system? First basic concept, system. The term system has a specific meaning in thermodynamics. Suppose this is a cylinder and this cylinder is fitted with movable and frictionless piston, and in this system a finite quantity of matter, suppose 1 mole of gas is enclosed inside the cylinder. This is nothing but system, and hence we can define the system by scientific way. A finite quantity of matter may be solid, liquid or gas, whatever it may be, a finite quantity of matter enclosed in a cylinder fitted with frictionless and movable piston called system. Okay. Or in a simple manner, we can suppose we enclose 1 mole of a gas in a cylinder fitted with movable and frictionless piston. This gas is nothing but a system. Then there is one more important term, surrounding. Second term. What is surrounding? Anything outside the system is nothing but its surrounding, which has direct effect on the system. Suppose the cylinder which contain 1 mole of a gas, 1 mole of gas, and suppose this is a system and this system is placed in constant temperature bath, then constant temperature bath is nothing but surrounding. Hence, I told you that everything outside the system which has direct effect on the system is called surrounding. To understand this, or to understand the term system and surrounding, I am again going to told you that consider a cylinder containing a gas placed in some constant temperature bath. Constant temperature bath may be a sand bath or oil bath or ice bath, whatever it may be. Anything outside the system which has direct effect to the system is nothing but surrounding. And in this case, the constant temperature bath is surrounding, and the cylinder enclosed a finite quantity of matter is nothing but system. Remember that the wall of the cylinder, constitute the boundaries. Okay. Now, there is one more term, basic term, that is universe. What is universe? Third term. When we consider system and surrounding simultaneously, then it is nothing but universe, or in a simple manner we can say that when system and surrounding considered simultaneously, it is called universe. Then type of system. Depending on the interaction between system and surrounding, the system are distinguished as open system, closed system, and third one is isolated system. But these three systems, open system, closed system and isolated system, depends on the interaction between system and surroundings. Okay. Suppose we consider first open system. What happens in open system, or when we can say that the system is open system? A system in which exchange of both mass and energy is possible between system and surrounding, then such type of system is called open system. Suppose this is a glass, and inside glass this is a hot water, and consider another second glass which containing cold water. When we pour the hot water into cold water, or when we transfer the content of glass A with or to second glass, then it is found that this is the open system, because in this system both matter and energy are transferred. Or suppose this is a cylinder fitted with friction and movable piston, and this cylinder consists of 1 mole of gas. Suppose these walls of the cylinders are made up of conducting material, and the material of the piston is also conducting material. What I say? We consider a system. Okay. Now, what happen? What is the difference between these two? Here, there are two systems. This is the first system, and in this system hot water, and in another system cold water. We can exchange both matter and energy. Okay. So, in a simple word, we can say that a system in which exchange of both matter and energy is possible between system and surrounding, then such a type of system is called open system. Okay. Now, another type of system, closed system. In closed system, suppose we consider, in order to understand closed system, consider again a cylinder containing 1 mole of the gas, and when we increase the pressure on the piston, what happens? The piston is moving in inward direction, and compression of the gas takes place. If the walls of the cylinder is perfectly conducting material, then heat energy can be transferred to the system. Here only exchange of energy is possible, but matter cannot be exchanged between system and surrounding. So, this is a closed system, and this closed system is very popular in thermodynamics. A system is said to be closed system if it can exchange only energy but not matter with the surrounding. Okay. See once again what happens in closed system. When we increase or decrease the pressure on the piston, it is found that there is exchange of energy from system to surrounding. When we increase the pressure on the piston, gas get compressed and energy is transferred to the surrounding. When we decrease the pressure on the piston, what happens? System absorb the energy from the surrounding and expansion of the gas takes place, and that in this way exchange of energy is possible and not exchange of matter is happen here. So, this is a closed system. Now, isolated system. Again consider the same system, only difference is that if the walls of the cylinder is perfectly insulating and the material of the piston is also perfectly insulating material. We are going to consider third system. This is isolated system. In this system is isolated system. Why? Because here we are going to consider a system, that means here a 1 mole of a gas is enclosed in a cylinder fitted with friction and movable piston, but the wall of the cylinder as well as the material of the piston is perfectly insulating material. When we increase the pressure or when compression of the gas or expansion of the gas takes place, then neither heat is given nor taken from the surrounding. Neither heat is given to the surrounding nor taken from the surrounding. That means what? There is no exchange of energy and matter, and hence this type of system is called isolated system. Okay. Now we are going to consider one more basic term in thermodynamics, that is thermodynamic state. This is very important. Thermodynamic state. What is thermodynamic state? The state of system. Thermodynamic state means thermodynamic state of the system, and the state of a system means a particular condition of system described by measurable quantities like pressure P, volume V and temperature T. And one more parameter is there, entropy S. I am again going to repeat this. A state of a system means the particular conditions of system described by measurable quantities like pressure P, volume V, temperature T and entropy S. Pressure, volume, temperature and entropy, these are the measurable parameter, or these are called variables. Okay. And hence with the help of these parameters or variables or coordinate, we can describe the state of the system. Suppose this is a change. Here at point A, if we consider the pressure on y axis and volume on x axis. Suppose at point A pressure is P1, volume is V1 and temperature is T1. And when suppose this is a system, initially this system consider 1 mole of a gas. Suppose volume of this gas is V1, here initially pressure is P1 and temperature of the gas is T1. When we decrease the pressure on the piston, what happens? The piston is moving in outward direction. Initially the pressure of the gas is P1, volume of the gas is V1 and temperature of the gas T1. When we decrease the pressure from P1 to P2, that means here pressure is P1, and when we decrease the pressure, this is the final pressure P2. When we decrease the pressure from P1 to P2, what happens? The volume from V1 to V2, here volume goes on increasing. And if the walls of the cylinder and metal of the piston are insulating metal, absolutely temperature of the gas goes on decreasing. So at point B, that is final position, pressure is P2, volume is V2 and temperature is 2. In this way we can, suppose this is the initial, this is the initial state and this is the final state. In initial state, how we distinguish initial and final state? At initial state, these parameters are P1, V1 and T1 at point A, and when process is completed, after completion we will get new parameter P2, V2, T2. Suppose these are the final parameter, and in this way, suppose in this way we can say that this is initial state and this is the final state, and hence the state of system means the particular condition of a system described by measurable quantities like pressure, volume and pressure, volume, temperature and entropy. Okay. Now here these parameter, that is pressure, volume and temperature. These parameters or variables or coordinates are called as thermodynamic variables or thermodynamic parameters or thermodynamics coordinates. Okay, this is very important. Again here remember that the state of system can be described in terms of its pressure P, volume V and temperature T. Suppose that initial state pressure is P1, volume is V1, T1 and temperature is T1. Then here the system, we can say that the system is said to be in initial state, whereas pressure P2, volume V2 and temperature T2 occurs after some time, then system is said to be in final state. Okay. Now this is about the introductory part of thermodynamics. Now we are going to start for actual fundamental of thermodynamics. First point is very important point, equation of state. What is equation of state? Remember that all these points are very basic points. You are already familiar with these points. You already studied this in 11th and 12th science. Here we are going to just elaborate something which are not possible at higher secondary stage. Now here equation of state. Question is arise that what is equation of state? A mathematical relation between pressure, volume, temperature for a system is called equation of state. Very simple definition. What is equation of state? A mathematical relation. A mathematical relation between pressure P, volume V and temperature T of a system is called equation of state. The equation of state for 1 mole of gas, we know that PV is equal to nRT. This is the equation of state. For 1 mole of gas, that is N is equal to 1. For 1 mole of perfect or ideal gas, perfect equation or perfect gas equation is nothing but PV is equal to RT. That is P into V is equal to R into T. This is the perfect gas equation. Okay. This is nothing but equation of state. And this is the equation of state for 1 mole of a perfect gas or ideal gas. In this equation, P is the pressure measured in Newton per meter square or dynes per centimeter square. Now here V is the volume occupied by the gas, and this is nothing is in cubic meter per mole or cubic centimeter per mole. T is the temperature which is measured in degree Kelvin, and R is the gas constant. R is gas constant. So it is having the value 8 into 3 1 into 10 raised to 7 ergs per gram degree Kelvin. This is the value of gas constant. Remember this forever. Now here remember that the pressure P, volume V and temperature T are not independent variable. Let me see, pressure of the gas is decrease, then volume can increase and vice versa. Also, if the system is made up of or system is isolated system, completely isolated system, obviously when compression or expansion of the gas takes place at that time, along with change in pressure and volume, there is a change in temperature. So, remember that here pressure, volume and temperature are not independent variable, these are dependent variable, depend on each other. If there is a decrease in pressure, obviously there is increase in volume, and if system is isolated, then obviously during expansion temperature of the system goes on decreasing, and during compression temperature of the system goes on increasing. And hence I told you that this is very important because pressure, volume and temperature are not independent variable. Consequently, the thermodynamic state of homogeneous system is determined completely by knowing any two values or variables out of three variables. R is constant. If we know pressure, we are having the value of pressure and volume, we can determine the temperature. If we are having the value of temperature, value of T and V of the gas, then we can determine the pressure. Or if we are having the value of pressure and temperature of the gas at a particular stage, then we can determine the volume of the gas. Okay. Now, there are certain limitations for this perfect gas equation. What are the limitations? Limitations of equation of state. What are the limitations? There are certain limitations. First limitations. The equation of state is valid. The equation of state is valid only when the gases are in thermodynamic equilibrium. What I say? The equation of state is valid only when the gases are in thermodynamic equilibrium. There is no perfect gas equation for the gases which are not in thermodynamic equilibrium. So, this is very important. I am again going to repeat this. The equation of state is valid only when the gases are in thermodynamical equilibrium or thermodynamic equilibrium. Okay. Second limitations. Every thermodynamic system has its own equation of state. What I say? Every thermodynamic system has its own equation of state independent on the others. Have you got it? Okay. Third limitations. An equation of state expresses the peculiar behavior, the specific behavior of one individual system which distinguish from the others. This is also very important limitations. And the last but not least, an equation of state is not theoretical deduction. Remember that the equation of state is not a theoretical deduction from thermodynamic, but is an experimental backing to it. It is having experimental background. Okay. Now, see here. Some important aspects regarding equation of state. We know that. Now, here we see that we studied equation of state is PV is equal to RT. For a fixed mass of a gas, suppose for 1 mole of a gas, this is fixed mass of a gas. If temperature is kept constant, R is gas constant, then what happen? PV is equal to constant. This is the perfect gas equation. And for fixed mass of a gas, that is suppose for 1 mole of a gas, if temperature is kept constant, then the product PV is equal to constant, because R is already constant. R is gas constant, and if temperature is constant, then constant into constant, the value is also constant. So PV is equal to constant, and this is nothing but what? This is nothing but Boyles law. Again I am going to repeat. For a perfect gas, we have the gas perfect gas equation is PV is equal to RT. For fixed mass of a gas, if temperature is kept constant, then we have PV is equal to constant, and this is nothing but Boyles law. This is called Boyles law. The perfect gas, remember here, this is very important. The perfect gas obeys Boyles law and K.J.S.COLLEGE law. Boyles law and K.J.S.COLLEGE law under all conditions of temperature and pressure. What I say? The perfect gas or the ideal gas obeys perfect gas or ideal gas obeys Boyles law and K.J.S.COLLEGE law under all the conditions of temperature and pressure. However, the gases like CO2, H2, NO2, that is carbon dioxide, hydrogen, then nitrogen dioxide. These gases are not perfect in this sense. Such gases are called what? Such gases are called real gases. These gases obeys Boyles law only when temperature is high and pressure is low. What I say? Very important. These gases, real gases, obeys Boyles law only when temperature is high. Temperature is high and pressure is low. Then and then these gases obeys Boyles law. Otherwise not. At high pressure and low temperature, these gases shows variation, deviations. What I say? Real gases like CO2, H2 and N2, these are the real gases, because these gases, when we study the behavior of these gases, then it is found that at high temperature and low pressure, these gases obeys Boyles law. But when instead of low pressure, if pressure is high, and instead of high temperature, if temperature is low, temperature is high and pressure is low, at that time these gases obeys real gases. But when temperature is low and pressure is high, at that time these gases does not obey Boyles law, and these gases shows maximum deviations or shows considerably deviations. They shows considerable deviation from ideal gas law. They does not obey ideal gas law, and the deviation is maximum in such gases, or the deviation is maximum for those gases which are easily liquefied. Okay. When we study the next point, that is Boyle's temperature, then we can understand the deviation for such type of gases. Now, suppose PV is the product which is taken along y axis and pressure is taken along x axis. It is observed that in real gases, for a fixed mass of a gas, the product PV is not constant but is a function of pressure. Now here, when suppose P is the product PV, we can suppose we consider fixed mass of gas, and if temperature of a gas for perfect gas or for ideal gas, if temperature of the gas is kept constant, then PV is equal to what? PV is equal to constant, and this is shown by this line. So here at say TB. What is TB? See here. For every gas, there is a certain temperature. For every gas, there is a certain temperature at which product PV remains constant with pressure. Though there is a variation in pressure, but product PV remains constant. I am again going to repeat, for every gas there is a certain temperature at which the product PV remains constant with pressure. Then we can say that for every gas there is a certain temperature at which product PV is independent of the pressure and Boyles law is obeyed. Then this temperature is known as Boyles temperature. What is Boyles temperature? TB. I am again going to repeat. What is Boyles temperature? Very simple. For every gas, Boyles temperature is nothing but a temperature. Which temperature? For every gas there is a certain temperature at which the product PV is independent on pressure P, and the gas obeys Boyles law, and the temperature is called Boyles temperature. And this is the characteristics of every gas, or this is the characteristics of each gas. Above the Boyles temperature, the product PV increases with increase in pressure, and this is above Boyles temperature. Okay. Now below the Boyles temperature, the product PV decrease, first reaches to minimum and then increase, that is below TB. What happened? Below Boyles temperature, the product PV decreases, or product PV first decreases, reaches to minimum and then increases. Okay. This is about Boyles temperature. Boyles temperature is very important concept. Okay. Now in next lecture we will see van der Waals equation. Why the van der Waals equation is there, or when, in short, in brief, I can say that as there are certain limitations for equation of state, that is PV is equal to RT is having certain limitations, and this equation is applicable, or this equation for real gases are valid only for high temperature and low pressure. And when pressure is increases and volume is decreases, then these real gases does not obey the perfect gas equation, and hence it is necessary to modify the perfect gas equation. And the van der Waals modified this perfect gas equation, and hence in next lecture we will see the van der Waals equation of state. Till then we shall stop here. Have a good day. Thank you.